Hello everyone, my name is Hunter Caskey, and today I will be demonstrating my team's work for part 2 of the course project for DevOps and Secure Software Development, which is a class offered by Ross Young and Jeff Garanzik at the Johns Hopkins University Whiting School of Engineering. I am presenting on behalf of Team 7 today, which also includes my teammates Lucas, Garbs, and Clint Sullivan. So today I'll be giving a brief walkthrough of the configuration steps that our team took to set up a CI/CD pipeline job that performs static code analysis on Juice Shop, which is an open source, intentionally insecure web application that's used for DevOps training and cybersecurity awareness. The pipeline job is the culmination of using Docker to automatically deploy a GitLab and SonarQube instance that have been integrated together. GitLab is used to house the source code and version control, as well as to perform the CI/CD processing, and SonarQube is used to perform the static code analysis scans of the project and to store the results persistently. After walking through the infrastructure, I'll demonstrate how SonarQube can be used to analyze defects and security vulnerabilities within the application to improve code quality and application performance. So in order to actually set up the infrastructure, our team used a tool called Docker Compose to automate the deployment of 3 different services. One is called Web, here, as you can see in this Docker Compose YAML file. And this web instance points to an image, a Docker image that is for GitLab. We have 2 more, one for Jenkins, which is used for part 3 of the project, so you can ignore this for now, and then another one for SonarQube. Each of these specifies a bunch of configuration components needed to launch the containers through Docker, such as whether restarts are valid, a hostname, environment variables, as well as a collection of ports used for the web GUIs and file system resources for reading and writing data. So in order to actually use this script to kick off the automation deployment, you would do something like sudo docker compose up, and this has to be done from within the directory of the Docker Compose YAML file. So I know that it's already located here, so we're good to start this process up. So I enter that command, and this command will take a while to run because GitLab takes several minutes to start up. If we go into another terminal though, I can show you that running the sudo docker ps command, we can see that all of these services are kind of just starting up now. So up for 19 seconds for SonarQube and Jenkins, and GitLab is currently in the process of starting. So I'm going to pause the video here and come back in a few minutes once everything is up and running. Alright, so as you can see now, all of the services appear to have deployed successfully. And additionally, if we go into Firefox, we can see that GitLab and SonarQube are both operational and accessible via a traditional web application. So next up, I'd like to talk a little bit about the exact configuration steps that our team had to take in order to perform an integration between GitLab and SonarQube properly, and to ultimately get a static code analysis for the Juice Shop repository up and running. So in order to get automated scanning on our GitLab repos with SonarQube, we had to create a personal access token off of the GitLab admin account. So as you can see here, if I scroll down a little bit, this is the admin's profile within GitLab, and you can see that a SonarQube access token has been created for the SonarQube application. This is consumed by SonarQube. If I go to this next tab, you can see in the Application Lifecycle Management Integrations tab pane within the just general administration settings page for SonarQube. If we go into GitLab, we've already configured the integration for the server, which is this information here. And if we go to edit here, it says that there's a personal access token that's purposefully hidden for security reasons, but you can update it if you ever had to revoke one access token and reassign it within SonarQube. So that is the steps that we had to go through in order for SonarQube to have access to GitLab. And firstly, we had to generate a separate access token that's derived from SonarQube, which is right here. So this is the Analyze Juice Shop token that's available on the administrator account page within SonarQube. This token is in turn used within GitLab. I believe it's under variables here. Yeah, so it's under GitLab and it's a configuration for the Juice Shop. It's under settings and it's under the configuration settings for CI/CD. So we have this environment variable called Sonar token, and this is the value that was given through the SonarQube admin user's personal token page. So we had to integrate that here in order for GitLab to have access to use SonarQube to push results out as a result of the static code analysis. We also had to have a environment variable here for the URL, and this is just a variable that points to the SonarQube server so that GitLab knows where to look and what APIs to direct. So after setting up those two sets of access tokens between the two applications, we have bidirectional communication, which kind of primes the stage for performing these pipeline jobs. So I'll close these out. From there, we had to create a different file called Sonar Project Properties. And this is a file that's committed to the root of the Juice Shop repository. And it basically just defines some general variables that are required for SonarQube to perform a scan properly. So it has the project key, and this is an index that's used within the SonarQube server for the project that we'll be looking at in just a moment. And then it has some other fields such as a quality gate that wait set to true and a URL. So all these were needed in order for the scans to kick off properly. After we generated that file, we had the final step of generating a .gitlab-ci.yml or YAML file. And this file controls the CI/CD runners for GitLab. GitLab was already configured to look for a file of this name for all repositories by default. So when we added this, it was automatically picked up once we committed the file. And this lives under the root of the Juice Shop repository as well. So this GitLab CI YAML file instructs the runners to pull down the SonarQube image and run a scan on a target that's specified by that Sonar Project Properties file that we just looked at. And now I can show you quickly the instructions for how we actually created the GitLab runner, which I have in this gedit file. So these are the two instructions that we used. The first command creates a GitLab runner, and the second one here commands the command registers the GitLab runner for our project. The registration command will prompt the user for project specifics for the GitLab repo, which includes that registration token. This information about the GitLab runner that's created from the CLI here is stored within GitLab, and we can actually see that under the CI/CD settings page, which I believe I have open. So yeah, if you go into admin, Juice Shop, CI/CD settings, and then this is a specific runner, you can see all the information that was inputted through the command line shows up here under a general information page. So once the GitLab runner was up and running, we were actually able to kick off jobs and have them run. And those can be seen within GitLab. So they're all kept under the Juice Shop CI/CD jobs page. And what you're seeing here is the example output from running job number 14 for the Juice Shop project. So as you can see, it's kicking off the Docker executor, pulling source code, and then down below here, you can see that SonarQube is doing a scan of the project for vulnerabilities, code smells, and defects. And each job that's kicked off here is tied to a specific commit hash that's in version control within the repository here. So once this job completes, these scan results get put into SonarQube. And we'll see that in a minute, and all of the items that are identified show up as code smells, vulnerabilities, and security hotspots. So moving on, as you can see here, I have SonarQube loaded up with the results of the build. So let's first go to the overview page. Just one moment. So here on the overview, it's tied to a branch. So we just have a master branch in our repository. When we go to overall code, we can see that out of the box, there was a number of defects. So 137 bugs, 203 security hotspots, and over 1,000 code smells. So there's a lot of technical debt and issues that should be addressed with this project if it were to be a real production application. So now that we've looked at the overview, I think we should take a quick look at 3 different types of issues that SonarQube reports for the code base. So as I mentioned, they have bugs, security hotspots, and code smells. We'll be taking a closer look at some of the security hotspots just because these tend to have a high level of risk for a project, but in reality, all of these categories should be given sufficient attention on a real project. Alright, so let's go on to the first security hotspot that we have picked out. Alright, so as you can see on this left pane, we're looking at the security hotspots, and SonarQube actually classifies them according to what type of vulnerability they are. So going from high to medium to low priority in terms of how you should review these, we can see that authentication tend to be some of the highest level priority items that you should review. So what SonarQube is saying here is that it's they actually point out the specific line items in the code that are a problem, and then it's nice because SonarQube provides an explanation of what is the general risk, and they tie it to the known community issue, the CVE number that specifies the vulnerability. There's another page here that says how can you contextualize this specific vulnerability within the context of your own project, and it helps you to identify whether it's actually an issue for your own project or not. And finally, SonarQube is nice because it offers you a mitigation step for how you might resolve this code. So for example, in this case, for most of the hard-coded credentials, the mitigation effort that they specify is to store passwords through the environment variables and access them that way rather than storing them in plain text within the actual application binaries. So that's just one example of an authentication security hotspot. So let's take a look at the next one that I have picked out. Guess my links didn't work. Give me one moment. Alright, so if we look at a code injection category bug, so these are being flagged by SonarQube because it's an evaluation that there is potentially malicious user-supplied expressions that are being evaluated by the application. Whenever using input from a user, great care must be taken to ensure that the input is not executable. Otherwise, a classic instance of arbitrary code injection could be apparent, leaving the actual application open to running untrusted instructions, which could prove disastrous. Finally, we can look at a denial of service security vulnerability. So these types of vulnerabilities are important to analyze because what is happening here is, in this example, there's a file upload happening, and the underlying issue behind file uploads is that you need to be careful that you don't allow the user to supply potentially arbitrary arbitrarily large file. Otherwise, the server could spin forever trying to upload it, or it could actually crash the hard drives or memory on the server. So it's always a good idea when you're doing these types of operations to put a limit on the file size to be uploaded. In this specific example, you can see that the code is actually specifying a maximum file size right here. So if you see the limits dictionary, it's specifying a file size of 200,000 bytes, which is well below the mitigation that SonarQube actually says, or I'm sorry, well below the threshold. So SonarQube is specifying 2 megabytes or lower for most requests that aren't a direct file upload. So since this is going to memory, this would be considered the other category. So this is an example of something that's being flagged by SonarQube that's actually compliant, but it's good to always make sure you double check these types of operations because they are potentially dangerous for an application. So with that, using this panel as well as these other measures, code, and issues tabs within the project in SonarQube, a developer can track code smells, bugs, and continuously be able to improve the quality of the code base they're working on and ensure that a secure end product is available for their users to use. That's about it. I hope this demonstration of what our team did for part 2 of the course project was interesting and informative, and I thank you for watching. Have a nice day.